Thanks, Al. And thank you to everybody for coming. And I think you're in for a really nice day. I wanted to start by talking about one of the things I started before. Let's see if we're a little bit lucky. One of the things I started before coming to UCSD was, 10 years, you can probably hear my accent, I'm an import. And 10 years ago when I came to the US, my dean at the time at Georgia Tech gave me a very simple mission. As long as you double your budget every 4 years, I'm not going to bother you. So I said, okay, I can try and steal money from the other robotic centers, so I can try and grow the pie. And I decided it's easier to grow the pie than it is to try and get other people's money. So we wrote a national robotics roadmap, and I want to talk a little bit about that. Because the third robotics roadmap is actually being published this weekend. So I want to talk about, sort of the national perspective, and then other people here will talk more about what we're actually doing on campus. So the good news is that we're going through massive growth for doing robotics, whether it's on the manufacturing floor, in services, or helping first responders. We're seeing an enormous growth for using robots. We're going from mass manufacturing to mass customization. We're no longer getting the same product. And I'll talk about this in a minute. But also we're getting this tremendous growth in unmanned vehicles, which if we look at it sort of from a roadmap perspective, has gone much faster than we predicted. I'm the one that normally says that kids born today will never get to drive a car. And now all the automotive companies are saying, oh, you're way too conservative. 2020, we will all have autonomous driving vehicles as a product you can buy. This opens up for a number of very interesting opportunities. And of course, at the same time, as Al mentioned, we are all seeing an aging society. And the question is, how can we empower people to live longer in their homes, to have a quality of life without having to worry about this? And technologies like Internet of Things and other things are helping us empower these people and providing technology that would allow us to do this. So if we look at first the mass manufacturing, the mass customization, I showed a very nice Audi A4 here. It was not to promote German cars. It was to it's a car that's available in 4 million different configurations, to the 24th different configuration options. This poses a serious challenge from a logistics point of view. So if you look at it, there are 256 steering wheels for an Audi A4. If you're trying to set up a manufacturing line, it has to be incredibly lean because you need to make sure everything is lined up. On a good automotive factory today, the storage time is 8 minutes. Products arrive and 8 minutes later, they're installed in a car and they're on their way out. We need to be able to live in a world where we can automate this. This also opens up for the fact that we can now bring jobs back, because doing mass manufacturing in Southeastern Asia is not necessarily the solution anymore. Given that we have these highly customized systems, we might as well do it much closer to the market. And that's why we're seeing Apple, we're seeing Lenovo, we're seeing BMW building factories here. You might not know this. All BMW X cars are built in the US. BMW is the largest exporter of cars in the US. This says something about Detroit, but that's a different story. But it's also interesting to see we're getting driverless cars. So we're starting to see these. And one of the things, of course, is that we're starting to see all of these experiments. We don't quite have necessarily the legal framework to be able to do this. But it is interesting. And there it's very interesting to how can we make sure we have contextual information. For today, if you have a Tesla, you might, legally, you're required to sit like this while you're driving so that you can take over at a moment's notice. I've seen YouTube videos of people sleeping on their way to work because the autonomous driving cars, and the chance that you're going to take over at a moment's notice is not quite there. So we need to figure out how do we fuse this technology in such a way that people can actually do this seamlessly. We're also starting to see where we do vehicle to vehicle so Volvo recently did an experiment where they drove from northern Germany to Lisbon with no intervention. And there was a safety driver in the front car, but the rest of them was just basically doing platooning. I think this also opens up for a number of new, not only services, but new business models. So I'm one of those guys that's always late for the airport. And I would love to have dynamic toll lanes so that when I'm getting ready to go to the airport, I can put $20 on the dashboard and ask the guys in front of me, how much is it worth to you to get out of the way so I can get to the airport? So, dynamic toll lanes, why only have sort of the left-hand lane for this? Why not just do dynamic toll lanes? You tell me what it's worth for you to get to a particular place, and I'll tell you what it's going to cost you. So there are new business models that we need to think about. So vehicle to vehicle is going to be incredibly powerful for doing this for all sorts of applications, but also making sure that we actually bring along the passengers. How do we do this in a reasonable way? And as Matt already hinted at, there's no doubt we're going to see an enormous amount of drone technology getting out there. And of course, we're seeing high-tech companies doing this, and they have a lot of interest, whether it's Amazon or Qualcomm or others. But it's very interesting for somebody that used to be in Atlanta, that UPS has started to do testing of drone technology for deliveries. UPS is probably the most conservative company I've seen in the US. They're very, very conservative. So when they said, we are ready to do drone delivery for the last mile, I was like, damn. Our biggest obstacle for doing this is not a technology obstacle. It's a legal obstacle. How do we integrate this into civilian airspace? And unfortunately, FAA is being very, very conservative about how quickly we can do this. So that's one of the challenges we have. The other we're going to see is that we're going to see a significant amount of aging, as I already mentioned. Already in Japan, 50% of the population is above 50, and we are getting in the same direction. So we need to figure out how can we do this. Same time when you move from Europe and you move to the US. In Europe, you have all sorts of TV commercials about the latest Audi and the BMW and all this. Then you move to the US and you get TV commercials about incontinence and high blood pressure. And I'm just like, really, people? This is the world we're living in? Unfortunately, it is. So we need to figure out, how can we empower these people to have high quality of life, do this, provide them so that we can take care of their mobility impairment, but also so we can take care of their cognitive sort of decline over time. How can we do this in such a way that people will stay as long as possible? I would like to be able to get out of bed, get dressed, take a shower, not necessarily in that order, and then be able to prepare a meal and be able to have participation in social activities. And how can we do this? And we think we can use robots to do this so that we're really changing sort of the life. So we started out, as I mentioned, 2009. I presented the first version of the National Robotics Roadmap, and got enough interest that President Obama took an interest. So 2011, we launched the National Robotics Initiative that's funded now about $400 million. 2013, we did a second, that was sort of around the presidential election. And now we're back to this presidential election, and we know we're going to get a new administration one way or another. So we are updating the National Robotics Roadmap, and I'm writing two different introductions. Writing one for Trump, and I'm writing one for Hillary. And I could bet on one of the horses, but why do I have to? I can do for both. And it will look slightly different. We're talking to both the transition teams about what this will actually look like. It was supposed to come out today. I worked on it until 1:30 a.m. this morning. There's still a chapter about ethics that the authors are having a hard time agreeing on what does ethics looks like for these robots. So we're going to put it out on Monday rather than today, simply because I can't afford to do it wrong. It's going to last for another administration one way or another. So but what's in here is that we're talking about how do we transform manufacturing. We're seeing manufacturing coming back. We're seeing an enormous volume of this. I brought up the Tesla example because they are one of the ones that have the highest degree of penetration of robots into manufacturing plants. It's also, they're doing it in California where you have the highest hourly wages, and still they have twice as deep a penetration into this because the car was designed for automation. Typically, people design a product, like I worked with Boeing, and when you look at it, I was like, did they talk to anybody before they started building this? Because the manufacturing people were not a guest at the table when they designed these airplanes. They actually designed it day one, so it was easy to automate. And because of this, we have a much higher. So we're seeing this coming back. We're seeing all sorts of manufacturing process where it's being used. So over the last 6 years, we've added 900,000 jobs to manufacturing, and we've had the highest growth in adoption of robots in industry ever. So there's a strong correlation between if you adopt robots, you actually also get more jobs. The other thing we're seeing is that we're seeing digital manufacturing. Manufacturing is becoming digital. I mentioned early on for the BMW factory, 8 minutes of storage time. So you need to be able to do this very well. So we need to think about how do we use Internet of Things in a manufacturing setting to be able to do very lean communication of doing these processes. So, of course, we've done a lot of analytics in the finance sector. We've done a lot of analytics even in real estate, and we are only now starting to see that we're adopting this. But it's also going to be very interesting that we're seeing an entirely new economy. So one of my former colleagues at Georgia Tech did sort of an analysis of all the IoT interfaces that exist today. There are about 30,000 of them. And then he analyzed who owns these. And you would think SAP, Philips, Siemens, Amazon, or Google, but who would own most of them? And I had a hard time. My bet was Siemens, or GE. 40% of all the APIs that are used in IoT today are owned by Amazon. 40%. Why? Because they release all of their interfaces in open source. So you get in through the door free of charge. Once you're in the house, we're going to make you pay for it. But, this is a way of being really smart about how you do this. Amazon is the second largest logistics company in the country. The largest one is Walmart. They have one interface in comparison, and you have to pay if you want to use it. So there's something to be learned here in terms of how do you build these ecosystems? How do we make sure we do this for autonomous driving cars, for drones, for all of this, so that it can be much more widely adopted? We're going to see Internet of Things for all sorts of services, both in terms of traffic and unmanned vehicles, but also in terms of house services. So we have to think about how we do this. In terms of professional services, clearly we're going to see autonomous driving cars, going to be a big deal. I still don't think it'll go that quickly, but also we're seeing lots of professional services such as cleaning. It's coming out, it's being used because all of the dirty, dull, and dangerous jobs are basically going to be taken away by these. We're also seeing concierge services. So if you go to Japan, Pepper is used by SoftBank in a number of different stores. So soon you don't have to go and actually talk to a person. It will be a robot that you will be talking to. And there we're seeing, of course, very smart cognitive systems. How do we make sure it's a natural dialogue so it doesn't break quite quickly? We're seeing lots of telepresence systems. And of course, we're seeing a lot of, as Al mentioned, we need to figure out how do we educate the future workforce for this? We are fortunate enough that most of us live in California, where we actually have a very strong educational system. Frank, who's speaking after me, and I both used to live in Georgia, where 30% of a generation of young people do not graduate high school. We need to figure out how we motivate these 30% people so that they actually want to be an active participant in the workforce. The easy way of doing this is to design the user interfaces so it looks like a computer game. The average 20-year-old American male has spent 12,000 hours playing computer games. He might not have a high school diploma, but he's an expert at gaming. So why do we not design user interfaces that looks like a computer game? It's in the thumbs. They can do this immediately. So we need to figure out, most of the interfaces we're designing today are not designed for the people that's actually going to use it afterwards. We, as the Contextual Robotics Institute, are very interested in understanding how do we model the humans and how do we build this interface so we can get fluency in how we design these. But it's very important overall for our country to be able to do this very well. Seeing lots of applications in healthcare. The ultimate is, of course, people like Al and others are working on nano and 3D fabrication. Joe is here somewhere. How can we do spare parts for humans? That's the long term. And we're starting now to see, for instance, we can do 3D printing of knees and hips. So rather than you getting sort of a new knee number 13, we can do a CT scan of your knee or your hip, and we can basically resculpture it in a CAD system, and we can 3D print in titanium a new hip or a new knee, which gives you a much higher quality of service. So medical robotics is seeing a tremendous amount of growth for doing this. The woman in the middle has a spinal cord injury. We can now use robots to strap her into one of those so that she can actually walk out of the room. So we've seen a number of examples of those technologies. Cyberdyne in Japan is a big proponent. So it can be used to help people with disabilities to be able to do this. But also we can help people potentially in the workplace for heavy lifting to be able to do this so that you don't have to do unergonomic jobs. And I don't have a picture yet of my elderly robot, so I have an illustration of what I think it'll look like. It will be a walker that will help people walk to, the community center. If they get tired, you can more or less sit on top of the robot, and now it becomes a wheelchair. But it also has arms that can go and do services for you, like bring you medication, do reminders, and say, are you aware of this, or preparing a meal for you. I still would like to get a robot that would allow me to help cook. I love to cook, so what if I could give the robot the recipe for Swedish meatballs, and as I start chopping onions, it says, I'm going to go and pick up the minced meat because I know he's going to need this in a minute. So how can I do this? High-level instructions that are high enough and build the intelligence into the systems so that we can do this. So that's going to be a big deal. And of course, we're seeing first responders, military systems is a big deal for this. We've seen a number of big successes, both in terms of using drones for getting awareness, as Matt mentioned, for forest fires. You might not realize this, but a lot of firefighters today, if there's a forest fire, literally draw where the fire is on a piece of paper, and then they fax it into a guy that then combines all the drawings into one combined map of where the forest fire is, and then he faxes it back and gives this to the firefighter and said, that's where the fire was 6 hours ago. How much help is that? So why are we not using this technology to get us much closer to where we can actually use this and give them real-time awareness of where are the challenges? Whether it's an earthquake zone, going into a defense scenario, this is going to be very important for us. And finally, we're starting to go Earth and beyond. How do we use robotics technology to go places where we can't go before? I'm sure you're all aware of the Mars missions that's been done for science discovery. We are now getting to a place where we can start doing sample recovery, or at least pick samples that could be recovered eventually from Mars. But also we're seeing NASA fly up, land on asteroids, and of course you can't do this teleoperated. So here again, you need to figure out how can the science crews work with this to be able to do. So we're seeing really cool technology, and soon we don't need to send astronauts onto the ISS anymore. We'll send up a robot and you can go home after 8 hours of work and take care of your family. It's going to be a little bit of a hard time getting people out of the ISS, but we have to try. So there's some really cool opportunities happening here. If we look over, we've done these every 4 years, so the question is where were big progress, where we were too conservative as. So the roadmap is written by, last time it was a team of 160 researchers. We underestimated the speed of driverless cars, how quickly it would be adopted. We thought it would be slower than that. It would be Google and a few others. Now, every car company has a division, even BMW. And you should all know BMW's motto is fun at driving. And they've been one of the very conservative ones because they said this will take the fun out of driving. But they are signing up now to do this because it's such a big deal that we can do this. The associated legal framework is still missing. So one of the things we're talking to DC about is how do we make sure we have a legal framework to do this? We can't have people just deploy this technology on the road and hope it will be okay. So that's going to be very important. We need major progress. We've seen major progress on aerial systems. It's amazing the number of systems, but it's also there we're really missing a legal framework. We need a framework for how can we coordinate these. Typically, for most of sort of the professional systems, it takes multiple people to run. You saw in Matt's video, there were, I don't know how many people it took to run one UAV. I want to flip it. I want to have one guy run 37 UAVs. That will be, I want to be the equivalent of the director. I wave my hands and there's enough intelligence that I get music. If I have to go and tell every UAV and have 10 people operate it, it's not going to fly. So we need to figure out how do we do, and Horsey will later on come and talk about how do we actually build sort of multi-robot systems so that we get this level of, I'm the director, but the rest of it will happen as a crew. We've seen tremendous progress on deep learning. So we're seeing deep learning being used everywhere for good reason. Same time, I would still claim that most of these results are, from a science point of view, amazing. From a commercial point of view, not good enough. So I see people get very excited about, we now have recognition rates of 90%. Okay, that implies that your robot is broken 2 hours a day. I can't sell robots that are broken 2 hours a day. I need to have 99.59s before I can sell commercial systems. I don't want to drive in a car that sort of breaks that often. So So Gil Pratt from Toyota recently gave this and said, human drivers drive something like 100 million miles between lethal accidents, or deadly accidents. So that's what we have to compete with. Can we design systems that's better than that? And if we can't, we're not competing. So we're seeing great progress, but we have to deliver. Of course, we're seeing collaborative robots. That's the next big deal. How do we break down the barriers? How do we make humans and robots collaborate in the same space? This is the fastest growing robotic segment today. And then we are seeing IoT for the consumer market. Slow progress. Grippers and manipulators still suck. And it's not because it's vacuum grippers. It's because, they're just really bad. So one of the areas where we've not made nearly enough progress is on grippers and how do we do effective manipulation. We're not even at a 2-year-old. Maybe we had a 1-year-old. So we need a lot more progress to be able to do this for everyday objects. Just to give you a sense for the complexity of doing manipulation, in your average grocery store, there are 45,000 different objects. Today people are very happy if they can manipulate 10 objects. That just leaves 44,900 something left that we can't handle. We need to be much better at this. And there we need fundamental new progress on how do we do better materials, how do we do much more agile mechanisms, and how do we combine them. So I would love to you might not be aware of this, you each have about 300 mechanoreceptors at your fingertips, and they have 4 different modalities. I want our materials people to develop new materials with integrated sensors that can do this, and then at the same time give it so they will work for the next 80 years. That's an interesting challenge for how we do this. And at the same time, we need to figure out how do we do systems engineering. Today, more than half of the cost for every system that's being deployed is systems engineering. And we can't afford to do this. If every car has to be done this way, it's just not realistic. So just to give you a sense, for autonomous driving cars, these are the number of players. And each of them have different standards and different software processes. So you can imagine this is just a pain, major headache. So we need to figure out how we can become much better at really doing plug-and-play kind of systems. Or the question is, how do we design new types of interfaces? With something like Internet of Things, can we rethink how we do most of our communication, as an example, so we can do much better integration than we can do today? So systems integration in most cases is not very sexy. Unfortunately, it's very needed because half of the cost goes into building this to make sure that we can do it. So some of the core research we're looking at is how do we do flexible mechanisms from nano to meso scale. We need to be much better at designing fundamental mechanisms to do this. We need to be able to build collaborative systems that are cognitive as well. So they have to be smart enough that they understand people. Too often today, we design systems and then we teach people how to live with it, rather than going the other way around and say, why don't we make humans the first-class citizen and design the systems around them? If I look at it, the typewriter is a great example of something that was engineered to make sure you were not efficient. That can't be how we do engineering anymore. We need to make the human the first-class citizen, model the humans, and then use this to build much better robotic systems. We need long-term mixed autonomy. And by long-term, I mean, the average industrial robot runs for 3 years without maintenance. We need to get to where cars can drive 100 million miles without even thinking about, am I wrong? So getting to that level of robustness is incredibly important for us, and we're not close. And I think it was Gil who said recently, most of the systems we're designing today is for the top of the bell curve. We need to do research on how do we cover the tails of the bell curve. That's where the hot problems are. The rest is easy. We can leave that to industry to do. But from a research perspective, we need to think about where are the interesting tails that we can go after for doing this. And we need robust perception. So most of the, I see lots of stuff that's being published and I'm like, yeah, this is a good feasibility experiment. It's not going to take us anywhere. And then we need to remember that we're getting access to data and computing resources that are extraordinary. There's just ridiculous amount of computing you can get access to today. And we're not leveraging it well enough so that we can do learning and adaptation, and we need to figure out how we can do this. The other thing that we're sort of talking about in the roadmap is how can we get access to shared infrastructure? So Al talked about the aerodrome. Most universities cannot afford to have an aerodrome simply because it's too expensive. The same thing, in Detroit, University of Michigan has an autonomous driving facility where they're testing DSRS and LT and other communication. Most universities can't afford to build a test facility for autonomous driving. So how can we share it? How can we do this? Because if we don't share it, we can't do comparative experiments. There's too many things for that. I flew at the UCSD campus on a sunny day where it was not windy. Like, okay, who cares? Tell me, how does it do in comparison to flying it at University of Pennsylvania or some other place? So we need to be able to do much better science and then make it accessible. So we should start, in physics, they share telescopes and colliders and things like that so that we can do comparative experiments. Robotics has to start doing the same thing to be competitive in the long term. So we need to do this and do sort of real comparative science. If I spend sort of the last minute talking about how does this then come back to contextual robotics. So in contextual robotics here at the UCSD, we want to empower people with robots. It's about how can we empower you whether you're in the workforce, how can we make sure you don't do the dull tasks and you leave sort of, today we typically use robots to do the fun part and then you're left to doing the other parts. We have to flip that and figure out how can we do this. How can I build this so we can use this for people that actually live in an everyday environment. We want to be the champions of long-term mixed autonomy. I want to be the one that designs I'm the director of the orchestra and then I have 32 drones that actually goes out and do whatever it is that they do. And we want to be good at doing systems engineering. We have a very strong set of people at UCSD that can help us do systems engineering so we can build the systems that in theory is plug and play and where the cost of deployment has to be 10% of the overall system cost rather than more than half of it. And one of our big places is sort of aging in place using robots. How do we empower people there? And of course, the other one is unmanned systems. How do we do air, ground, and sea? We're in the fortunate situation that we have amazing companies like Qualcomm. We also have Northrop Grumman. We have General Dynamics, General Atomics. We have Boeing here, but we also have Spavar. We have the Pacific Fleet. That opens up for an entire ecosystem for unmanned systems. So we are sort of perfectly located for this. And we don't have Silicon Valley prices. And we have better weather. So, how can you compete with us? For us, it's very important to think about how do we build systems that solve real-world problems. So we're looking at how do we build applications, how do we build realistic use cases, and how do we then understand the right balance between humans and robots to be able to do this in a reasonable way. So we really want to think about how do we bring all of these three together. We want, if you're not solving a real-world problem, you're wasting money or you're leaving money on the table. So we want to do this real-world applications. We want to understand the human, we want to understand the robot. So it's not just about automating everything. It's about finding the right blend between humans and robots, or the right confluence. So in summary, we're seeing with robotics a tremendous amount of growth. There's still a need for fundamental research. As I said, mechanisms, fundamentals control, really understanding the people, not just go sort of in steep, but really understanding where people are in this. And then we need to make sure that research actually gets deployed. If you don't deploy it, if you just write a paper and then go on to your next paper, you're losing an opportunity to have real-world impact on people's lives. So we want to make sure we can do this. And then we need to figure out how do we educate next-generation researchers, both here at UC San Diego, but also nationwide. In many cases, we need to figure out how do we start at K-12. Because if we don't get enough engineers or enough people that are trained in STEM, we can have the best possible engineering school in the country. We're just not going to get the smartest people to work on, I want them to work on robotics, but at least in engineering. And then finally, we need to make sure how we translate it. And today, the statistics for the US is that less than 5% of the research that's being done at universities gets translated into something that companies are doing. That's a serious sort of mistake that we don't actually do more of this. So we need to figure out how do we become better at formulating use cases with the companies, but also make sure once we've done the research, we translate it into how companies can actually use this. On sometime this weekend, the new National Robotics Roadmap will become available, and if you left your email here, we will send you a link to where you can download it on Monday and look at it. It's sort of a 100-page document that covers manufacturing, services, healthcare, defense, and space, and it will talk about all of those. And with that, I'll say thank you. And we might have a minute or two for a question, otherwise we'll go on to
Are there any
Frank.
questions?
There's one up there.
Thank you very much. Just one question. In first presentation, we saw word drone. In your presentation, UAV. Those words tend to have negative connotation. Is there a way to make a consensus and maybe change us as a community to something like flying robots or something more creative than that?
So we have deliberately in the roadmap used the word unmanned aerial vehicles because typically the press would use drones to have a very negative sort of military connotation. So we've been very deliberate in using that word simply because there are, and at least the science community is trying to figure out what is the right word to use to make sure that we don't get, because some of those names, you're right, some of those names comes with a very negative bias on, how do we use this? So at least we're trying to work, so I can't give you what is the answer, but I can tell you we are working very actively on figuring out how do we do the right naming.